Hey, this is Amos, the math guy. Before you watch the video, I just want to welcome you and say please feel free to subscribe to this channel where we'll be teaching the history and philosophy of math and science. We're bringing math to life for students around the world. Our books, our workbooks, Counting to Calculus, can be found on Amazon now. You can look them up, and so please check them out and share our channel with others. We're also starting small group tutoring and large group tutoring in 2025, where we go through with every student from the fundamentals of mathematics all the way to calculus. We have a diagnostic that shows us where they're at, and we guide them all the way to the destination. So please use the link in the description to sign up. I also have these flashcards that I'll be providing to students in the fall. So please reach out, subscribe, and make sure you stay tuned because we're about to change math and science education forever. Have a blessed day. Did you know electricity and magnetism are connected? Well, James Clerk Maxwell and Michael Faraday did a lot of work in this field. There are other people like Alexandre Volta and Ampere and Hans Ostad who did work as well. However, Maxwell's equations are the ones that kind of take the cake, right? Even though when you study his equations, you hear other names like Gauss's law, Carl Friedrich Gauss, and other key people are in the discussion of physics and mathematics. But let me do this. Let me explain a little more about Maxwell's life. James Clerk Maxwell was actually born in the year that Michael Faraday discovered electricity. That Michael Faraday discovered electromagnetic induction, which was 1831. One application, the electromagnetic telegraph, quickly followed, thanks to Gauss and his assistant Wilhelm Weber. Gauss wanted to use wires to carry electrical signals between Göttingen Observatory, where he hung out, to the Institute of Physics a kilometer away, where Weber worked. Presently, Gauss simplified the previous technique for distinguishing letters of the alphabet, one wire per letter, by introducing a binary code using positive and negative current. By the way, Carl Friedrich Gauss, phenomenal guy. He was a prodigy, born in 1777 and lived for 77 years. So what happened here? So basically, by 1839, the Great Western Railway Company was sending messages by telegraph from Paddington to West Drayton, a distance of 21 kilometers. In the same year, Samuel Morse independently invented his own electric telegraph in the U.S., employing Morse code invented by his assistant, Alfred Vail, and sending its first message in 1838. In 1876, 3 years before Maxwell died, Alexander Graham Bell took out the first patent on a new gadget, the acoustic telegraph. It was a device that turned sound, especially speech, into electrical impulses and transmitted them along a wire to a receiver, which turned them back into sound. We now know it as the telephone. He wasn't the first person to conceive such a thing or even to build one, but he held the master patent. Thomas Edison improved the design with his carbon microphone of 1878. A year later, Edison developed the carbon filament electric light bulb and cemented himself in the popular mind as the inventor of electric lighting. In point, he was preceded by at least 23 inventors, the best known being Joseph Swan, who had patented his version in 1878. In 1880, 1 year after Maxwell's death, the city of Wabash, Illinois, became the first to use electrical lighting for its streets. These revolutions in communication and lighting owe a lot to Faraday. Electrical power generation also owed a lot to Maxwell. But Maxwell's most far-reaching legacy was to make the telephone seem like a child's toy. And it stemmed directly and inevitably from his equations for electromagnetism. We're going to be talking about Maxwell's equations. We're going to get a board. We're going to get some notes. We're going to write some things down. Or I'll find a video. Let's do this. I'll find a video and link it in the description later for Maxwell's equations. But Maxwell's story, wow. Okay, so stay tuned for 12 Men That Changed the World. We're going to focus on Maxwell and Faraday in 2025. This relationship literally changed science. Maxwell was at the Cavendish Laboratory, which he started in the 1870s at Cambridge University. That's the Department of Physics. And we have Faraday, who did work at Royal Institution. He was an assistant first to Humphrey Davy, and that was back in the early 1800s. So the Royal Institution in London, the Cavendish Laboratory at Cambridge, these two men meet. Maxwell takes Faraday's work and takes it to the next level, adding the equation component. It is important for us to collaborate with people and allow people to use their strengths to help move our mission forward. I look forward to sharing with you about 12 men that changed the world. And we have a series as well of 12 women that changed the world in mathematics and physics, Marie Curie being one of them. And so stay tuned, math and science history to inspire you. We'll bring in math to life here on Counting to Calculus. Have a blessed day.